Air is a mixture of gases. It surrounds our earth. We cannot perceive it when it is calm, but it is felt when the air is in motion. The total mass of air is held around the earth because of the earth's gravitational force. Study at a glance. Air, composition of air, structure of air, weather, climate. Air. The air is a mixture of gases. Thick blanket of air around the earth is atmosphere. The atmosphere comprises of numerous gases, water particles, dust particles, etc. These gases, water particles and dust particles are necessary for the support of our life and that of plants and animals. We inhale and exhale in this atmosphere. Water vapor is also necessary for us. It is the source of rainfall without which we cannot live. Composition of air. The atmosphere is composed of several gases, water vapor, dust particles, etc. The important gases are nitrogen, oxygen, argon, carbon dioxide, neon, helium, hydrogen, ozone, etc. By volume, nitrogen is 78% and oxygen about 21%. Together, these two gases make 99% volume of the atmosphere. The rest, 1%, are many other gases which are very less in volume, but they are also important for us. Nitrogen is used by the plants for their survival. But plants cannot take nitrogen directly from the air. Bacteria that live in the soil take nitrogen from the air and change its form so that plants can use it. Oxygen is vital for the survival of humankind and nitrogen is vital for plant life and in turn for animal life. Green plants use carbon dioxide to make their food and release oxygen. Ozone protects us from the ultraviolet rays of the sun. The dust particles become base for the water vapor to rest upon and thus form a layer of cloud which gives us rainfall. Structure of air. The atmosphere extends to over 1000 kilometers above the surface of the earth. The densest mass of air is near the earth's surface and it becomes thinner and thinner as we go higher and higher away from the surface. The atmosphere is divided broadly into the following layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, the ionosphere and the exosphere. The troposphere. Troposphere is the lowest layer of the atmosphere. It lies closest to the Earth's surface and extends to 9 kilometers high over the poles and 18 above the equator. It contains almost all the gases, water vapor and dust particles. The survival of humankind and other organisms depends on this layer. The upper boundary of the troposphere is called Tropopause. Here the temperature decreases at the rate of 1 degree Celsius per 165 meters. This is known as lapse rate. The stratosphere. The stratosphere lies above the troposphere and its average height is 50 to 55 kilometers. The narrow zone of separation between troposphere and stratosphere is called tropopause. It is free from clouds, dust particles, water vapors and convectional currents. The temperatures are very low and fairly constant. This layer is ideal for flying of jet aircrafts. One important feature of the stratosphere is that it contains a layer of ozone gas which protects us from the harmful effect of sun rays. The Mesosphere. Third layer, that is middle layer of the atmosphere, is called Mesosphere. The average height is about 80 kilometers. Its upper boundary is called Mesopause. Meteorites burn up in this layer on entering from the space. The Thermosphere. The thermosphere is the layer of the Earth's atmosphere directly below the exosphere. Within this layer, ultraviolet radiation causes ionization. The temperature in the thermosphere is very dependent on solar activity. The ionosphere. This layer extends above mesosphere up to a height of about 400 kilometers. The radio waves transmitted from Earth are reflected back by this layer. Thus, it helps in radio transmission. It is a zone of ion gas, electrons and atoms. It helps the conduction of electricity in this layer. It contains electrically charged particles called ions. The exosphere. This is the uppermost layer of the atmosphere. The upper height is not known due to inaccessibility. It gives way to interplanetary space. Weather. Weather is a particular state of atmosphere prevailing over a small area for a short period of time. Weather is never static, it is dynamic. It changes within a short period of time. It varies from place to place. Even within one town, it may be sunny on one side while it may be cloudy on the other. Weather instruments. Various devices used for recording various aspects of the weather are thermometer. Thermometer is a device used for measuring the temperature. Barometer. Barometer is a device used for measuring atmospheric pressure. Wind vane. Wind vane is a device which shows the direction of wind. Anemometer. An anemometer is a device that is used for measuring wind speed. Climate. Climate is the sum of all weather conditions prevailing over large area for a long period of time. The climate of India may be described as monsoon type of climate. The climate stands for a generalized picture of the weather conditions of a given place. Hence, the elements of weather and climate are the same. Elements of weather and climate. The elements of weather and climate are the following: temperature, pressure, wind direction and humidity. Atmospheric temperature. Our Earth has no light and heat of its own. It receives heat from the sun. The surface temperature of the sun is estimated to 6,000 degrees Celsius. The sun continuously radiates its energy known as solar radiation. On the basis of heat received by the Earth, we may divide the Earth into the following heat zones: torrid zone, temperate zone, frigid zone. Torrid zone. Torrid zone lies between the Tropic of Cancer and Tropic of Capricorn on both sides of the equator. Here, the sun's rays are almost vertical throughout the year. This zone receives maximum heat and is the hottest zone of the Earth. Temperate zone. The temperate zone lies between the Tropic of Cancer and Arctic Circle in the northern hemisphere and between the Tropic of Capricorn and Antarctic Circle in the southern hemisphere. In this zone, the sun's rays never fall vertically. This zone is neither too hot nor too cold. Frigid zone. Frigid zone lies to the north of Arctic Circle in the northern hemisphere and to the south of Antarctic Circle in the southern hemisphere. Here, the sun's rays are very slanting. This zone receives very low amount of heat. Hence, this is a very cold part of the Earth. heating and cooling of the atmosphere. Sun is the only source of atmospheric heat, but it hardly affects the atmosphere directly. The high mountain summits are often covered with snow, while plains are warm. The atmosphere is heated in the following ways: through radiation, through conduction, through convection, through advection. Through radiation. Radiation is the direct heating of an object by the transmission of heat waves. The atmosphere absorbs a little amount of incoming solar radiation, but it largely absorbs the outgoing radiation from the Earth's surface. Thus, the atmosphere is heated more by terrestrial radiation rather than by incoming solar radiation. Through conduction. Conduction is the process by which the heat is transferred to matter by molecular activities. When the lower layer of atmosphere, which is in touch with the ground, comes in contact with the upper layer, the heat particles move from lower to the upper layer. Thus, the atmosphere gets heated up. Through convection. It is the transfer of heat by the movement of a mass or substance from one place to another. When the air in the lower layer of the atmosphere gets heated, it expands and moves upwards, and the air from different sides come to take its place. Thus, convection currents are formed by constant rising of air. This heats up the atmosphere. Through advection. When the wind moves from a warm region towards a cooler region, it increases the temperature. And when a wind moves from a cooler region towards warm area, it reduces the temperature. The temperature of the atmosphere cools down or heats up due to horizontal movement of the wind. Factors controlling temperature. The temperature is the degree of hotness or coldness. The atmospheric temperature does not remain the same everywhere. It varies from place to place because it depends upon a large number of factors. They are latitude of a place, altitude of a place, distribution of land and sea, ocean currents and vegetation cover. Latitude of a place. The angle of incidence of sun's rays is not the same everywhere due to the spherical shape of the earth. The angle of incidence is high on and around the equator and goes on decreasing towards the poles. Altitude of a place. The altitude of a place controls the temperature. The higher we go, the cooler it becomes. This is because atmosphere is heated indirectly by the heat of the earth, that is, terrestrial radiation. The places at lower altitudes or plains are warmer. Distribution of land and sea. The distribution of land and water bodies also controls temperature. During the daytime, earth gets heated quicker than the sea water, and during night, the land releases heat more quickly than the sea water. Ocean currents. The warm ocean currents along the coast help to increase the temperature of a coastal area, while cold ocean currents help to decrease the temperature of a coastal area. Vegetation cover. The forest cover and other plant life absorbs much of the heat received from the sun. The vegetation also prevents quick radiation from the earth. Thus, the desert areas having no vegetation gets heated more quickly during the day, and at night they release the heat and get cooler quickly during the night time. Measurement of temperature. Temperature is measured by an instrument called thermometer. A thermometer is a narrow glass tube which is graduated and filled with mercury or alcohol. It works on the principle that mercury expands when heated and contracts when cooled. There are two different scales for measuring temperature: Fahrenheit and Celsius or centigrade. Atmospheric pressure. Atmospheric pressure is defined as the pressure exerted by the weight of the air on the Earth's surface. The atmospheric pressure can be measured by an instrument called barometer. The normal atmospheric pressure at sea level is about 76 centimeters of the mercury column in the barometer. Horizontal distribution of pressure. Whenever there is increase in the temperature of the air, it gets heated and expands in volume and becomes lighter. Due to less weight, the heated air rises up, causing low pressure. But at high altitude, the same air gets cooled and becomes heavier, and thus it descends down, causing high pressure. Vertical distribution of pressure. Atmospheric pressure decreases with height. The decreasing rate of pressure with increasing height is variable. As we go up, the atmosphere becomes thinner and thinner, and its pressure also goes on decreasing. This is the reason why high pressure is found at the sea level due to dense atmosphere. The lower areas or plains have high pressure, but on the mountains the pressure becomes low. World pressure system. The main pressure belts of the world are the following: equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, polar high pressure belt. Equatorial low pressure belt. Equatorial area is a region of high temperature. Due to intense heating, the atmosphere heats up, expands and becomes lighter. Hence, the air starts rising up in vertical ascent, causing low pressure on the ground. The horizontal movement of wind in this belt is very feeble. It is therefore a calm belt. It is also known as doldrums. It is a zone of wind conveyance. Subtropical high pressure belt. This belt extends between 30° and 35° latitudes in both the hemispheres. Here, the winds are comparatively dry and calm. This is a zone of descending winds and wind divergence. This region or belt is often referred to as horse latitudes. Subpolar low pressure belt. This belt extends between 60° and 65° latitudes in both the hemispheres. This is a zone of wind convergence. The rotatory movement of the earth causes low density of atmosphere over this belt. Hence, the atmosphere over this belt is thin, and thin atmosphere can exert only low pressure. Polar high pressure belt. Around the North Pole and the South Pole, the temperature remains low, and thus a permanent high pressure develops over the poles. Wind system. Due to horizontal difference in air pressure, air flows from area of high pressure to area of low pressure. This movement of air is known as wind. A wind is named after the direction from which it blows. Example, the wind blowing from west is called westerly. There are different types of winds: permanent winds, periodic winds, and local winds. Permanent winds. The winds which blow throughout the year in a particular direction and over a particular region is known as permanent winds. They are also known as prevailing winds or planetary winds. They are the trade winds, anti-trade winds, polar winds. The trade winds. Winds tend to blow from high pressure to low pressure, but they are deflected to the right in northern hemisphere and to the left in southern hemisphere. This is as per Farrell's law of deflection. So, the trade winds blow from the subtropical high pressure belts towards equatorial low pressure belt. East being the common direction, they are also known as easterlies. In the olden days, these winds were useful for the traders. That is why they are called as trade winds. Anti-trade winds. These winds blow in the opposite direction of trade winds. They blow from subtropical high pressure belt towards the subpolar low pressure belt. West being the common direction, they are also known as westerlies. Polar winds. These winds blow over the polar region from the poles towards the subpolar low pressure belt. Their direction is the same as that of the trade winds. That is why they are often known as polar easterlies. Periodic winds. These are the winds which blow over a particular period of the year in a particular definite direction over a particular area. These winds develop due to unequal heating and cooling of the surface of the earth. The periodic winds or the seasonal winds are also called monsoons. Monsoon winds. Monsoon winds are seasonal winds which blow from sea towards land mass in one season and then from land towards sea in the other season of the year. During summer season, the landmass heats up rapidly and an intense low-pressure area develops over Central Asia, which attracts the winds from high pressure. As a result, the southeast trade winds cross the equator and blow over the Southeast Asia and bring heavy rainfall to several parts of Asia. These are known as summer monsoons or southwest monsoons. During winter season, the landmass becomes cooler and the pressure over Central Asia becomes high. From this high pressure area, the winds blow towards equatorial low pressure area in the northeast direction. These are known as winter monsoons or northeast monsoons. Local winds. Local winds blow over a limited area and have local significance. They are of two different types. Land and sea breezes. Mountain and valley winds. Land and sea breezes. Land and sea breezes develop due to the difference in the rate of heating and cooling of land mass and the sea. During daytime, the land heats up quicker than the sea. Thus, a local low pressure area develops over the land and high pressure over the sea, and the wind begins to blow from sea to land, known as sea breeze. During night, the land releases the heat quickly and becomes the area of low pressure, while the seawater releases heat very slowly. Thus, there is high pressure over the land and low pressure over the sea, and wind begins to blow from land to sea, known as land breeze. Mountain and valley winds. During the day, the sun's rays fall on the mountain tops, so the temperature begins to rise, causing low pressure on mountain tops. In the meanwhile, valley has low temperature because it is protected by mountain ranges. So the valley has high pressure and the wind begins to blow from the valley towards the mountains. These winds are known as valley winds. During the night, the mountain tops get cooler because they release the heat quickly, while the valley, being protected by the mountain ranges, releases the heat slowly. Thus, high pressure develops over the mountain and low pressure over the valleys, and the winds begin to blow from mountains down to the valley, known as mountain winds. Lu. It is a hot and dry wind which blows over the plains of North India during summer season. Chinook. It is a warm and dry wind which blows over the eastern side of the Rocky Mountains in North America. It is often known as snow eater. Humidity. The amount of water vapor or the moisture present in a given volume of air is termed as humidity. It helps in cooling and heating of the atmosphere. The actual amount of water vapor in a given volume of air is known as total humidity or absolute humidity. The ratio between the actual amount of water vapor present in a given volume of air and the water vapor which the same volume of air can contain till its saturation level is called relative humidity. Condensation. Due to decrease in temperature, the water vapor starts converting into liquid water droplets. This process is called condensation. Condensation has various forms. Dew. On cool nights during winter, when the earth radiates heat and gets cooler, then the air which comes in contact with the cool ground also becomes cooler and water vapor starts condensing over the grass, trees, leaves, etc., which could be seen in the early morning. This is called dew. Frost. When the temperature falls down to 0 degrees Celsius, the water drops form ice crystals which are known as frost. Fog or mist. Fog is formed by the condensation that takes place on the dust particles floating near the Earth's surface. It can be seen during the peak winter season. Clouds. Clouds are a mass of minute droplets of water formed by the condensation of water vapors in the upper atmosphere. On the basis of this appearance and the altitude at which they occur, the clouds are classified into the following categories: nimbus clouds, cumulus clouds, stratus clouds, and cirrus clouds. Nimbus clouds. These clouds occur at low levels. They are dark grey or black in appearance. They cause heavy rainfall. Cumulus clouds. They appear like a cauliflower. They are often white or greyish. They are also the rain-bearing clouds. Stratus clouds. They appear like thin sheets in the sky. They are whitish and they hardly bring any rainfall. Cirrus clouds. These clouds look like the bird's feathers. They are often known as feathery clouds. They do not bring rainfall. Precipitation. Precipitation is the process under which the condensed water vapors fall on the ground in various forms such as rain, snow, sleet, and hail. Rainfall. Rainfall is the falling down of moisture from the atmosphere in the form of liquid water drops. Rainfall is of three types: convectional rainfall, relief rainfall, cyclonic rainfall. Convectional rainfall. When the air comes in contact with the hot surface of the earth, it gets heated, becomes lighter, and starts rising up. Thus, convectional currents are formed. On reaching the upper layer of the atmosphere, the air starts cooling. Then, condensation takes place and clouds are formed. And if a critical temperature is reached, then the rain occurs. This is called convectional rainfall. Relief rainfall. When the relief features such as mountains come in the way of a moist wind, then the wind is forced to rise up the mountain. The rising wind starts cooling and then condensation takes place and the clouds are formed. Cyclonic rainfall. Cyclones are the centers of low pressure. The air converges from all directions towards the low pressure. It is forced to rise up. The rising air gets cooled, condensed, and clouds are formed, which ultimately bring rainfall. Summary. Air is a mixture of gases. The total mass of air surrounding our Earth is called atmosphere. The atmosphere is broadly divided into the following layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, and the ionosphere. Weather is the atmospheric condition prevailing for a short period of time. Climate is the average atmospheric condition of an area. The elements that go on to make up climate are atmospheric temperature, atmospheric pressure, wind system, and humidity. On the basis of heat received by the Earth can be divided into the following heat zones, namely torrid zone, temperate zone, and frigid zone. The atmosphere is heated through radiation, through conduction, through convection, and through advection. Latitude of a place, altitude of a place, distribution of land and sea, ocean currents, and vegetation cover are the factors that control temperature. The major pressure belts of the world are equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. The different types of winds are permanent winds, periodic winds, and local winds. The amount of water vapor or the moisture present in a given volume of air is termed as humidity.